Okay, we're going to have a look at the homework that was set for algebraic fractions. What I'm going to do is I'm going to look at the centre section, okay, and in that centre section I'm going to do in effect the whole of that question 2, question 5 and question 8, okay, just in case anyone is really struggling on how to do it. Also, what I'm going to look to do is, because I'm going to do that section, that still means you've got plenty of homework, in the sense of I want you to do question 3, 6 and 9, which is going to be slightly more difficult, okay, and I will explain what we're going to do down on question 6. I won't complete the question, but I will explain the processes of doing that. Okay, so I'm just going to blow up into this so we can see it a little bit clearer. So first off, question 2c. If I'm looking to simplify this, I'm going to simplify by in effect cancelling normal terms. So if you think what we did in class, we've got 2 and then we've got x times x times x. I'm just writing it out, if you like, in longhand, and I've got 6 and x. Remember, I can cancel anything below by above by what's below. So how many factors can I take out of the 2 and the 6? Okay, so I've got the 2 here and the 6 here, so I can divide both by 2. So if I divide by 2, I end up with 1 at the top, and divide that by 2, it gives me 3. Okay, if I've got an x on the bottom, I can cancel an x on the top. Okay, so I've got 2x cubed divided by 6x, so that's going to equal x squared. I've got 2 x's, divide by, and all I've got left on the bottom is 3. So x squared divided by 3 is my answer. So I've cancelled the numbers as much as I can, like I would normally on a fraction, to simplify, and I've got rid of one of the x's. Collated the other 2 x's to the x squared, and that's that one we've done. Question 5. We're following the normal rules of fractions, so to be able to add or subtract a fraction, I need to get the bottom number, the denominator, the same. So these two numbers will have to be the same to enable me to add or subtract initially. So we're still following the general rules of fractions. Okay, I can get that the same as the other side by multiplying it by 5. So I'm going to times the whole of this fraction by 5 to make sure the denominator is the same. So I've got 5 times 6 over 5 times x, which is going to equal 30 over 5x. All I've done is multiplied that fraction by 5. I'm then going to put in the other fraction that I've got, plus 7 over 5x, and I can now add it, 37 over 5x, and that's my answer. So again, remember, when we get to this stage here, bottom of the fraction will not add. I'm not adding that because that's the denominator of my fraction as normal. So whenever you're adding fractions, okay, bottom denominator will stay the same, and we would add the top or subtract the top. Okay, going on to question 8. Same sort of thing, in the sense of I've got to get the bottom of the fraction the same. Now, if they're not factors of each other, okay, then your easiest way to do it is just do the smile method. So kiss, kiss, smile is what it's called. Well, is one name for it anyway. Okay, the cross multiply method. So I'm going to multiply the 3 by the 10 to give me my denominator. 3 times 10 is going to give me 30. That becomes my bottom number. Now, because I've multiplied the 10 and the 3 together, I've got to also multiply the top of the fraction by 10. So all I'm going to do initially is I'm going to write it out, 10 times x minus 4. So I'm going to, again, I'm putting a bracket in so that I'm getting it to a point of being able to see what's happening. The next one, I've multiplied the 10 by the 3, so I need to multiply the top of the fraction by the bottom denominator. So 3 times x minus 5. That's my first step done. Next, I'm coming down the line and I'm going to expand out the brackets. So 10 times x gives me 10x. 10 times negative 4 gives me negative 40. Plus 3 times x gives me 3x. 3 times negative 5 gives me negative 15. And that's all going to be over 30. Okay, what I'm going to try and do now is collect like terms. So like we did earlier, we've got 10x, 3x, x terms, we've got number terms, and I'm going to combine them together. Okay, so 10x and 3x is going to give me, is going to give me 13x. Minus 40, take away 15, is going to give me minus 55. And that's all going to be over 30. And that would be my answer. 13x minus 55 divided by 30. So looking at that one, the cross multiplication rule for adding and subtracting fractions works exactly the same as it would normally do. The only difference is instead of doing 10 times, I could times that out directly if I wanted to. I could go 10 times x gives me 10x, 10 times negative 4 gives me negative 40. If I want to do that in one step, you can do. Okay. The only reason I've put it in brackets like I have up here, okay, is I'm telling the examiner that that's what I want to do. I want to times 10 by the whole of the top of the fraction, and I'm timesing 3 by the whole of the top of the fraction. You choose whichever way works best for you. Okay, question D. Again, we're back to a point where I'm just going to write out what I've got. 6 times x over 18 times x times x times x. Exactly the same process. I'm just going to cancel them down. 6 goes into 6 once. 6 goes into 18 3 times. X goes into x. And this time, what have I got left on the top of the fraction? Okay, because I've cancelled everything. Remember, 6 goes into 6 once, so it's a unit fraction with 1 at the top. Everything else has been cancelled. What have I got on the bottom? I've got my 3 and I've got x squared. Okay, so my answer would be 1 over 3x squared. On B, same rule of thumb, I'm going to try and multiply my fraction out. Okay, I've got 9x here and I've got 3x here. Okay, so if I times the bottom of the fraction together, I'm going to end up with a quadratic. I'm going to end up with an x squared term. Okay, and I don't really want to do that. So if I times this whole side of the fraction by 3 and I times this side of the fraction by 9, I should get the same denominator. Okay, so 3 times 10 gives me 30. 3 times 9x gives me 27x. Take away. Now again, if you think, if I now divide that by 3, I end up to where I started. The other side, timesing it by 9. 9 times 2 is 18. 9 times 3x is going to give me 27x. I've got the same denominator. Okay, now I can take it away. I'm just going to put one denominator down, 27x, so I don't risk taking them away. And I've got 30, take away 18, which gives me 12 over 27x. Now, that's almost done. If you're thinking about, if again, always think, does anything divide into the top and the bottom? In this case, 2 doesn't. Does 3? Well, 3 goes into 12 4 times, and 3 goes into 27 9 times, so I'm left with 4 over 9x. Okay, so again, similar to the cross multiply method, I'm timesing that side by 3 and I'm timesing that side by 9. The only thing I'm not timesing is the whole of the bottom number. Hopefully that makes sense. Okay, we've got one more to do. So we're going to look at cross multiplication again. I've got two whole numbers at the bottom, integers at the bottom of my fractions that I can just multiply out. So again, cross multiplying, because I'm timesing the 3 by the 4, I'm going to times the whole of the side of this fraction by 4, and because I'm doing it the other way around, 3 is multiplying the 4 this way, I times this side of the fraction by 3, so times by 3. Now I'm going to write it out again in the brackets just to show you and highlight one of the reasons why. Okay, so I know the denominator is going to be 12. Okay, so 4 times 3 is going to give me 12 on the bottom of each side of my fraction. Okay, on the top, 3 times x minus 9. Okay, and then 4 times x minus 2. Okay, so that's what I've got. So 3x minus 9. Now if I convert that fraction, I'm going to just put the line straight across. Remember the bottom of my number, bottom of my fraction is going to be 12. Okay, so get rid of the 12s on the bottom and just write one denominator of 12. Okay, now I've got that. If we expand the top of the fraction, 3 times x gives me 3x. 3 times negative 9 gives me negative 27. Minus 4 times x gives me minus 4x. Okay, and minus 4 times minus 2, 2 minuses, is going to give me positive 8. Now if I did it up here and I just times each digit out, I'm going to miss the fact that that's a negative 4 when I've written it in the fraction down here. Okay, so you could get it wrong because 4 times negative 2 would be negative 8, and we can see in the fraction down here it's positive 8. Okay, so just take care. Writing it in this method at the top here will help you miss errors like that. So now I'm going to collect like terms. I've got 3x, and I'm going to take away 4x, which is going to give me minus x. I've got negative 27, and I'm going to add 8 to it, okay, which is going to give me negative 19 all over 12. And that's the solution to that question. Good luck on the rest of your homework, guys.